welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. I'm your host, Dr. Moiya McTier. I'm an astrophysicist and folklorist, and I am recording from my office here at Pale Blue Podiversity, and I'm expecting a stellar guest. Dr. Chanda Prescod-Weinstein is a theoretical cosmologist, a particle physicist, a professor of physics and gender studies at the University of New Hampshire, an earring connoisseur, and an author. Their new book, The Edge of Space-Time, Particles, Poetry, and the Cosmic Dream Boogie, comes out this week, and I'm so excited to talk to her about it. Chanda, come on in.
Hi, thank you for having me.
Oh, it's so great to have you here and your earrings. How are you doing?
I'm doing pretty good. I hope you and the listeners will not be able to hear the construction the city decided to start doing outside my house without warning me. So
Naturally.
If you hear any weird noises, I'm fine.
No, I think we're pretty good. The Podiversity office has great insulation, so we don't have to deal with that. Your new book comes out this week. How are you feeling about it?
You know, it's my second book, so
Yes.
It's a little bit scary. I don't know, in a weird way, the anxiety for a second book is different from the anxiety for a first book. I think because there wasn't a lot of expectation that my first book would do well coming into release week, the fact that people were being positive about it was just like, you know, icing on the cake that it was actually doing okay. But because that book did well, it actually puts a lot of pressure on the second book. So I'm really anxious. I went through a period where I was like feeling some shame and negativity about the book. And I think that I've come out of that. And now I'm feeling pride about the book and excitement. And I'm starting my book touring this week. And I will be book touring basically for 3 weeks straight.
Wow.
So I'm hopeful I'll get to have some really fun interactions with people, get some really good questions from people. So that part's exciting.
Yeah, I hope you do too. If they've read advanced copies of the book, they will definitely have good questions because there's just so much in there. Before we dig into the content of the book, selfishly, as an author who's about to put out their second book, I'm curious, what did you do to get over that shame? Because I'm definitely feeling some of that.
I think some of it was actually not paying attention to the book.
Ooh.
Like, I just had to put the book down and be like, I'm done with it right now. There's this kind of weird period between when you are done with copy edits and when you're done with the third, whatever number past pages you're on, and everything's finalized and it's gone off to the printer, where you're kind of oddly suddenly not doing anything for the book because media interviews haven't started yet. But you also don't have any reason to be talking to anyone. But also you're trying to tell people on social media, my book is still coming. So there is kind of this weird time period where you're like, what is my relationship to the book right now besides promoter? And so I think actually just not looking at the book for a while was helpful to me to get some distance from it so that when I looked at it again, I was looking at it with kind of fresh eyes. I definitely think that was part of it. And then also actually the media interviews, these conversations are really helpful because I get reflected back to me what people took from the book, what was interesting to them, what came up for them. I did an interview where we ended up talking about baseball a lot, and I got to bust out all of the things I know about Sandy Koufax. And that was an unexpected and fun. So I think that also helps situate things in context. I will say also, I recently realized that a sample, so you can read a sample of the introduction and of the first chapter on my publisher's website right now, and it will continue to be there once the book goes on sale. And seeing it placed on the site, formatted and making it publicly available, I was like, oh, actually, I think I stuck the landing with this introduction.
Oh, that's awesome. Yeah, the time away gives you the distance you need to see it with, how the reader sees it for the first time.
Yes, for sure. And to experience it as a reader to the extent that you can, given that you did actually write it.
Right. Yeah, you're so close to it. You need to zoom out and see the whole forest.
I think one of the hard things for me with my first book, with The Disordered Cosmos, actually, was that I knew that I didn't feel that the writing was at the level that I wanted it to be. I felt good about the arc of the book, about the discursive choices that I had made, about the storytelling choices that I had made, but I did not feel that my prose was at the level of quality that I wanted it to be. And I felt frustrated by that every time I looked at the text. I hated doing readings from it because I would be editing in my head while I was reading.
Yeah.
And I do feel that with The Edge of Space-Time, with the second book, that I felt much better about my prose. And so there is kind of that feeling of also the contrast between the two books, of seeing the way in which I have worked on my craft and improved. And that's something, regardless of whether readers see it, I see it. And that's kind of just something to feel good about as an artist.
Oh, I love that for you. That's what we hope as artists, that we'll continue to grow.
Yes.
Amazing. Well, you're not just an artist. You are also a scientist, and you do your own research. You lead your own lab. Can you tell the listeners what type of research you do and whether any of it made it into this book?
So I am primarily a dark matter researcher. For people who don't know, I mean, I'm sure listeners of your podcast know a little bit about dark matter, but for anybody who might be new or forgot, that's okay.
Yeah.
If you don't know what dark matter is, that's fine, because I don't either. So we're on the same page there. So we think that most of the normally gravitating matter in the universe is some invisible stuff that for historical reasons has the name dark matter. But the invisible part is important to emphasize. We think that light goes right through it, and that particles of light, what we call photons, don't really interact with it. If they do, it's a very mild interaction that we've never seen. And so we think that there's more dark matter in our galaxy than there is visible matter. So this is like a completely different type of matter than the stuff we are made of, than the stuff stars are made of. But it's also very important for the evolution of any kind of big structures in the universe, like the Milky Way, which Moiya wrote a beautiful autobiography for.
Thank you.
As told to Moiya McTier.
Yes. I was just a channel.
Right. So I focus in particular in trying to understand how we might use observations from astrophysics, so things using telescopes or maybe using gravitational waves, which are vibrations in space-time that we can detect, to tell the difference between different hypotheses, so different possible particles that might constitute the dark matter. And I've been very focused on a dark matter particle called the axion. So this is what I've spent most of my career on at this point. It's not what I did my PhD on, but it is what I came to as a postdoc. So that's primarily what I do. I've graduated 2 PhD students who have worked on that. I now have, this is an incredible thing to be doing right as you're launching a book and book touring. I have a second postdoc who's just joining my group. So I've been onboarding a second postdoc.
Wow. So you have so much free time.
I have so much free time. I don't have any graduate students right now, partly because of the federal funding situation and the complexities that has created for admitting students to graduate programs. But I do have 2 postdocs who are working with me. So we're doing a lot of calculations, computation. There's a decent amount of calculation by hand that's happening. And then we're putting things into a code that's going to run simulations. And we are testing some ideas that our colleagues developed and thinking them through. One of the great things about being a professor is you get to choose who you work with. And so I really think everybody I work with is fantastic. That's part of the fun part and I do write about this in the book. It's not a huge emphasis of the book. I think I will have more to say about that maybe in the next one.
Okay.
There is kind of this feeling of like, you have to be at a certain point in your career to really write a book that is centered on your research and your accomplishments. And I haven't felt like I was there yet, but I think I'm getting there.
Yeah, it's like a memoir. You want to have most of the story ready before you tell it.
Yes.
Mm-hmm. And I did see in this book, The Edge of Space-Time, that you feel most comfortable as a researcher when you're writing down the equations by hand and working out those calculations. Do you just have like notebooks and notebooks in your office?
I do. It's like, I have so many notebooks. I have backups too. So I basically have a store. I have a closet that's basically just bookshelves. And one of the shelves in there is just fresh notebooks of the different kinds, because I use a different type of notebook depending on what thing I'm doing. So when I'm writing a book, actually, I take notes by hand. Yeah. Like if I see a quote that I like, I write down the quote by hand and what I'm thinking about it. And that's actually the first stage. I don't make those notes on my computer. I do all of it by hand. So I have a particular type of notebook that I use for that. And it is different from the notebook that I use to take notes for physics research.
Like just a different notebook? Or are we talking like yellow legal pad versus spiral?
Different brands.
Oh, so you can really tell the difference. It's like sensory information that lets you know, oh, I'm working on something different now.
Yes. So I use Moleskine for my physics stuff, and I use Luke Term for my feminist science, technology, and society studies and book writing stuff.
Yes.
And then I have a third type of notebook, a spiral notebook, that's from a Japanese brand whose name is escaping me right now, that I use for scratch paper. And so that's my, you can say anything, the most shameful, I couldn't add 2 + 2, I kept thinking it was 5 type thing. Because I throw those out and I know that there's no chance that anybody will see whatever ridiculous thing I wrote down. And so that's where I do my, like, I'm trying to figure out a calculation. Once I figured it out, then I copy it back into my notebook.
That's such a beautiful peek behind the curtain. Thank you for telling us that bit about your process.
Thank you for asking. No one ever asked this question, so I love it.
Because I also, when I'm doing research for books in particular, take notes by hand, and it's always in a yellow legal pad. And every time I do anything else, it's in like a small spiral notebook. So I understand.
I like the paper with the little dots on it. So I don't like a full grid. But I like something that gives me a guide. I don't like lined paper. This is like, I'm very specific, and I am picky about the texture of the paper. So I am choosing the notebooks. Like, it has to be smooth. It has to have a certain level of weight to it. And some of that is I just know what I like, and I don't want to be distracted while I'm getting the work done by like, oh, this is irritating. I also have an array of fountain pens. Some of this is I have a disability in my right hand, and fountain pens you don't. Anybody else who has, like, I have what's called de Quervains, and this is known colloquially as mommy's thumb. I'm not a parent, so I did not get it from holding a baby, but it often happens when people are holding their thumb out like this. I got it from gripping my hand too hard doing calculations while I was a postdoc.
Because academia is dangerous.
Academia is dangerous. And it turns out with fountain pens, you don't have to push down to get the ink out because the ink just naturally flows. So that's one of if you're someone who has de Quervains or some kind of handwriting disability, I will just put that out there as a recommendation. And then also Pilot G2 pens can be useful. I go in and out of being able to use those. And I have a very particular blue ink that I put in most of the fountain pens. So all of this is just so like I will focus on the thing at hand and not the little things that are annoying me about, oh, I don't like the ink, I don't like the paper.
Yeah, that's what you need to do in your creative process. And I'm so glad you've found that for yourself. It took me a long time to find and then accept the different parts of my creative process because it didn't match what I had seen on TV or whatever. So that's so cool. And like, I bet the feel of the pen on the paper is very important.
Yeah, I mean, I went through a lot of different fountain pens where I was like, actually, I don't like where the weight sits in this pen. That's part of the design is where the weight sits. There's also figuring out what width of nib you like. And I figured out there were a couple of designs that I like. And so then if I wanted to have 2 different inks, I might buy that pen twice and just have in different colors so that I can tell the difference and then just put different inks. But I know what the nib is going to feel like.
I want to start a stationery podcast now because I want to keep talking about this. It's so interesting. But I do want to get back to the book itself. You say in the book that what makes physics hard is that you must be willing to change your worldview when data, when experiments, when other things don't match what you believe. Did you come across anything in your research or writing for this book that changed your worldview?
You know, one of the challenges that I gave myself when I was writing the book is that, and I think I say this in the book, I didn't really like Newtonian physics. I never had any joy in Newtonian physics, which is really unfortunate because that's also how we introduce students to physics. If someone reads a book like The Edge of Space-Time and is like, I'm going to go to college and major in physics, and then they get there and it's all like balls rolling down inclines, which I actually have in the book as a figure, right?
Yeah.
So one of the challenges there that I gave myself was, if this is going to be interesting to your reader, it has to be interesting to you. Because if you're bored, your reader is going to be bored. You can't make the case from a place of boredom, or at least I don't have that skill. I'm a passion-driven person, and so that passion has to shine on the page. And while I was reading about Newton's laws, I think I saw on Wikipedia that one of the laws was actually written down in some Zhao Kingdom philosophy like many centuries before. And Wikipedia is a great starting point for knowing things, but you do have to check the citations. And so when I went to the source for that, there was a mention of a book, but no page number. And so then I had to go look for that book. And then I had to figure out what page the information was on. And suddenly I was reading, I had found there are only 3 different English translations of this one text that predates the formation of China as an imperial kingdom, but is written in what we would call ancient Chinese. Mm-hmm. And spending time with that and realizing that there were these philosophers in that time period who spent a lot of time thinking about space, who spent a lot of time thinking about time, and who saw understanding those things as being significant to how everyday life was lived, was really fascinating. For me, anyway. I think the people around me, for the 2 weeks that I was really diving deep into that, it was the only thing that I would talk about for a while. Like I had a friend who I would talk to every single, like we had a call set up basically every 2 weeks. And so like during our 2-week call in that period, I think the first hour of the call was just me being like, did you know?
Let me tell you about the canons and explanations.
And I'm pretty sure we were on Zoom. I'm pretty sure I was like screen sharing. Like, yes. Here's my Zotero. Here's what I found. It's amazing. I think one of the cool things about that was realizing how dependent I was on funding for the humanities, because these translations were made possible because humanists had been given the opportunity to actually do the work. And these translations take a lot of time and they require a lot of fiscal support. And so I was also having this moment of really realizing how dependent I was as a scientist on people who were doing translations. That was also true. I went back and read parts of Newton's Principia to actually go back to the source, which, as you know, physics students are never encouraged to read the original text.
Yeah, I didn't see that original writing, the original wording of the laws until I was researching for the podcast.
Right. Exactly. And so I think that transformed my relationship and allowed me to humanize Newton as a thinker on the page a little bit, instead of as this god of physics, as he's kind of handed down to physics students. But again, that's a situation. The book's written in Latin. So that's another situation where I'm, again, dependent on translators and reading what the translators say about the challenges of with the ancient Chinese, of the debates in the literature about translating one character and the feeling that a character is intended to have, and their effort to give me, the reader, a sense of the limitations of their translation. So I think that was something that was really fun, and where I was learning things and helped me transform these questions of, even if I'm not thinking about relativity or quantum mechanics, why these questions of space and time are interesting from an everyday life point of view.
Mm-hmm. Yeah, because we don't think about it. It's just one of those things we accept, and we don't question unless we go into this line of work. But it is nice to know that people were really thinking about what is time and how does motion work for so long.
Yeah, I think in a lot of ways, what I hope with The Edge of Space-Time is not that people will take what I say on face value, but that actually people will ask questions about, I talk a lot in the book about metaphor. I start the book with a chapter about metaphor.
Yeah.
And one of the invitations that I hope I'm making is for people to say, yes, I understand that you have to communicate to me about science through metaphor, particularly if you're not using equations, which I also argue are a kind of metaphor in their own way in the book. Mm-hmm. But I want you to ask, what are the limits and the boundaries? What is the edge of that metaphor? If I go beyond that edge, the metaphor falls apart. And I want people to ask that question rather than take it face value. Well, that's the whole thing. And I think that part of that is like learning to ask questions and like push at the boundary of what has just been said to you.
Yes. Yeah. And know that humans have been doing that for so long. So you're practicing like an ancient tradition by being curious.
I think you're stepping into and embracing a very normal, everyday human behavior that I think people have done throughout the centuries. And, as I was thinking about writing about this, I do want to be very careful about universalizing, because culture is diverse, is globally diverse. Mm-hmm. But there are some things that we have in common. Language is obviously one of those things. Storytelling is one of those things. curiosity about the night sky and storytelling specifically about the night sky is also one of these things. And I know that that's something you've thought about a lot in particular. And relating those stories about the night sky to events here on Earth and laws that might describe how things work here on Earth is actually an ancient tradition. So this narrative that actually like Newton and Galileo were the first ones or among the first ones to make those connections, they made those connections through a particular framework, a particular mathematical framework, but they were certainly not the first ones to be asking those questions of whether there are laws that govern how things work on Earth and above.
Yeah, absolutely. And it's a good reminder that they also were dependent on humanists. They were dependent on translations too. Copernicus, Galileo, around that time, they were newly able to read ancient Greek texts, ancient Arabic texts that were translated for them.
Yeah, this was something that I was also thinking about a lot while I was working on the book, which is when I wrote The Disordered Cosmos, I had some knowledge and understanding about information exchange between the Muslim world and the Middle East and South Asia and West Asia and European scientists. But I felt like my knowledge about this had deepened a lot, and particularly because I had read James Poskett's new, I guess it's no longer a new book. I can't remember the title. I want to say it's called Horizon, A Global History of Science, but I'm probably messing that up. But he really tells the story in the book about how, for example, Copernicus almost certainly had seen a text that suggested that the Earth was not at the center of the solar system. And as a scientist, that made sense to me. I was like, oh, so the idea of the heliocentric model was him taking that model to another step of saying, well, what if it was the sun? And that made a lot of sense because often in science, it's actually how it works. Is someone makes a proposal and then someone pushes it a little bit, and then that turns out to be the more complete model. And that made a lot more sense to me than like, oh, he just came up with it. Like,
because when do we ever just come up with something in a vacuum?
Right.
Never.
Right. And the text he would have seen would have come from the East. And so part of what, for people who have read my first book, who read The Disordered Cosmos, you will see some evolution in kind of my thinking of how we should narrate the story of where science comes from. And I do think there are probably going to be some people who read The Edge of Space-Time and are like, oh, you know, she's pro-Palestine and really wanted to emphasize Muslim contributions and Arab contributions. And actually, that wasn't something I was trying to do. It was something that was naturally coming out because that was simply what the story was.
Right. That's just the history that you were covering factually.
That's just the history that I was covering. Of course, it is coming out in a particular political moment where I do think that it's important for us to be attuned to the way that Muslim contributions to society are diminished. And Muslim people their humanity is questioned and diminished, and Arab people as well. So I think I was conscious of that as I was writing, but I wasn't really like trying to shoehorn it. It was just kind of happening because that was what I was learning. And I think it also, in the process, transformed. When I wrote The Disordered Cosmos, I was thinking a lot about mechanism and this idea that we can write down rules for the universe that kind of mirror a mechanical function or how a machine functions. And I had always understood that to be a European precept. And as I was doing my reading, I realized I had to let go of that because it was actually something that was quite prevalent across the Muslim world, so including in Africa as well. And so there was also this element of me realizing that if I really wanted to fully engage with Black intellectual history, that meant engaging with Black Muslims. And so that was all part of my process of, again, re-engaging with Newtonian physics from a completely different angle. And I think I like it much more now.
Oh, good. It's like a spiral, not a circle, because you came back to the same point, but like a little level above.
I think, you know, one of the hardest things about writing the book was actually that everything felt like a loop and a spiral in my head. And a book is physically linear.
Yes.
And figuring out how do I cut the loop and turn it into a straight line, right? Especially if it's actually a spiral and not a circle. So it's not closed. I know you're a scientist, so you're like, I see what she's doing here with the topology. It's like a topological problem.
Yes. But also from an art standpoint, the cover of the book has this beautiful spiral image on it. So I think you might be forgiven by the readers if maybe the book isn't as linear as they might expect.
I will say with the cover of my first book, I did make some suggestions to the artist that played a really big role, and that I had actually been the one to suggest, let's do a silhouette of a Black woman or a Black person with the cosmos in their hair. For The Edge of Space-Time, I actually had almost nothing to do with this.
Oh.
Believe it or not, this was really, I was sent 5 suggestions. That was one of them. This was obviously, I think a lot of publishing houses and a lot of writers get the opportunity to fill out a form that says, this is what I want my reader to feel when they look at the cover. Mm-hmm. And I had said, I want my book cover to speak to queer readers, which I think is why the rainbow is there. I think that was, and I also said I want the book cover to speak to Black readers in a way. And so there's also this feeling of like 1970s, like disco, retro boogie feeling in it.
Yeah.
I think that's, I haven't actually talked to Tyler Comrie, who was the artist who did it. You don't get to talk to the artist. This is all filtered between you and your editor. The only part that I played is I spent a bunch of time being finicky about the lining up of the text here and where the break would be. I think my editor had about had it with me, but I do think it came out really nicely, and the design team did an incredible job. And because there's that boundary between the black and white side and the rainbow side, I was then actually able to write about the cover in the text and use the cover as a figure, basically, as an example of one of the concepts I was talking about. And that was fun.
Yeah, I saw that, which is why I'm now so shocked to realize that you didn't have much to do with the cover. It's just like a beautiful coincidence.
No, and actually, I have to say I was a little bit slow on the uptake of realizing, wait a minute, in Beyond a Boundary, I can talk about this as an example of a boundary condition, that there is like this transformation that has to be addressed.
Yeah.
That did not occur to me immediately.
It takes time. It's a journey to the realization. Hey there, friends. Chanda had to step out to take a call, so I'm going to use these few minutes to share some messages with you. The first message is a thank you to all of the patrons who support the show. Thank you. As an independent podcast, it would be so hard to make this show without your support, because we have to pay our editor and our hosting fees and all of those things. And we just really appreciate you. Thank you so much. And we want to give a special shout out to our Sun-like stars, Scott Reynolds, Tom T., Nicole Bartlett, Ashley Shambo, and Bruce Sedloff. Thank you so much. If you would like to join this awesome group of people in supporting an indie podcast, you can do that on Patreon. You'd get to hear your name on the show, make it onto the patron star chart, and get research notes for most episodes starting at $5 a month. That is at patreon.com/palebluepod, and the link is in the episode description. There's also a PayPal link in the episode description where you can become a supernova in our sky by making a one-time donation of any amount, and we would appreciate whatever you can give. If what you can give is not money right now, we understand, and we are still so appreciative of what you can do, like rating and reviewing the show on your favorite podcast app or sending a link to a specific episode to someone who you think would enjoy it. But no matter what you do, thank you just for listening. It's really awesome to know that Connie and I get to be a part of your week. So thank you. I want to recommend another show in the Multitude Collective called Wow If True. This is your one-stop internet culture shop, explaining how what's happening online shapes the real world. The hosts are the internet experts and real-life besties to unravel it all. One is tech culture journalist Amanda Silberling, and the other is science fiction author / attorney Isabel J. Kim Esquire. Isabel has a book coming out this summer, so I'm really excited to check that out. And you should be excited to check out their podcast. They just put out an episode about the literal worst song ever. They talk about a song that was released by the AI actress Tilly Norwood. It's ridiculous. Check out the episode. They make appropriate fun of it. So check out Wow If True wherever on the internet you find your podcasts. New episodes come out every other Wednesday. All right, Chanda's coming back so we can continue talking about this awesome book that is out this week. So go look for it. You mentioned metaphors before, and you say that you have this whole chapter about metaphor. Do you have a favorite metaphor that we use in science?
Oh, no, I wasn't prepared for this question.
I'm so sorry.
No. I mean, this is good because I think one that I write about in the book that I think I'm quite fond of is space-time as a fabric. And I talk about this in the book, I think partly because my grandmother was an extraordinarily talented seamstress who, even when my family could finally afford to buy prefabricated clothing, she was still making her own, and it was still better than anything that you would buy in the store. Mm-hmm. And so I think, particularly in Black families, there are important cultural elements to fabric and our relationships with it. And so I do think that that was a powerful one. I write about Bisa Butler's work with fabric and representing Harriet Tubman, and I use this as an example in the book. I actually tried to get permission from Butler's team, and unfortunately it didn't work out to include that Harriet Tubman work in the book. But I do encourage people to look that up. I believe it belongs to the Blacksonian, so it should be publicly available in the Smithsonian's online stuff. And Bisa Butler is like an amazing artist. But I do really think that the fabric metaphor is rich. And there are also limits. So I will say the other thing I really like is thinking about space-time as a rubbery surface.
Because it's bouncy?
Well, I think if you want to get that feeling for it stretching and curving, that happens more smoothly with a rubbery surface. I actually had a lot of fun a couple of years ago. I did Getting Curious with JVN. And literally spontaneously, I was like, it's like a dental dam. And I feel like I was aging myself in a way because I'm old enough that when I went to college, we were still very worried about HIV and AIDS. We didn't have PrEP. The medications that people needed to take, the prophylactics that people needed to take, these were all like really expensive. And so even for us queer ladies, we were learning things like how to cut a condom so that on the fly you can turn it into a dental dam, because condoms were freely available in dorms and dental dams weren't always. So, and I still think actually people should be thoughtful about STDs, and so that's a good argument for continuing to use dental dams, but I do think there's been a decline in emphasis on that. So I think I am dating myself a little bit. But I think a dental dam could be a really good metaphor for space-time. And you can always, if you want to like really get an intuitive sense for curvature of space-time, take a condom, cut it open, and put like a baseball on it. Or a hockey puck. Maybe that's like a good reference for right now. Am I sounding enough like I am 43? But yes, I can be cool,
so timely.
So timely. And then just watch as the dam changes shape or the condom changes shape. And this can give you some intuition for what it means for something massive like the sun to bend space-time. That was a really long, sex-filled wind-up to the sun causes space-time to curve.
That's okay. No, that is a great metaphor, and I can't think of a better metaphor that I've ever heard for the material structure of the universe.
Yeah. And the other thing is that there are limits to that, right? Because like the fabric, the dental dam, the condom, whatever you're talking about exists inside of our space-time. And so it naturally begs the question of what's outside of space-time.
Yes.
And the hard thing is that there isn't anything outside of space-time, right? So I guess I will say for specifically thinking about what space-time is, I think I quote this line from the analytic philosopher W.V. Quine, who basically said that a person represents, like, you can think of a space-time as the 3 dimensions of a person plus however old they are. So I have 3 dimensions in my embodiment, my physical embodiment, 3 spatial dimensions plus 43 years. And that can give you some intuition for what it means to bring space and time together. That's not so much a metaphor, but it does kind of play on our understanding of our lifetimes as space.
Yeah, it's good to be able to viscerally connect on that level, because there aren't many other opportunities for us to do that with something as large and long as the universe.
Yes.
But it seems like an important thing to consider in metaphor is the boundaries. Where does the metaphor work? Where does it stop working? You also have to consider boundaries for any creative project like this book. The edge of space-time covers so much. You cover quantum field theory, you cover the greed of the private space industry, like all over the place. How did you possibly determine what the boundary conditions of this book should be?
There were certain things that I knew I wanted to do for the book because they would just be fun for me. And I think in a lot of ways, this book was like, what's fun for me?
Good.
And part of it, I had just gotten tenure when I started writing the book. And so there was an element of this that was also about me going back to my roots. And as you know, there's a pretty big distance between the way we broadcast what physics is to the general public and then the pressures of you have to learn this particular skill set. And if you're working on foundations of time, for example, you'll be hard-pressed to find someone who will even supervise a PhD on that topic. You won't be able to get a postdoc in most cases. You won't be able to get a faculty position. And so there are all these things that you have to take a break from thinking about just to get to the next stage if you decide that academia is where you want to live your life. And mad respect for people who decide that that's not what they want to do because it doesn't give them the intellectual freedom that they want, right? I think that there is an element of that, which is like you're kind of picking your poison of the way in which you will be restricted. And the nice thing about writing a book is that that is a place where you can create that kind of intellectual freedom for yourself on the page, if only for a little bit. And so to come back to things that I definitely wanted to do, so actually originally I wanted to open the book with the chapter about the Stern-Gerlach experiment. So this is a quantum physics experiment. It's my favorite physics experiment of all time. From my point of view, it is the experiment that implies the entire artifice of quantum mechanics. If you can understand this experiment, or at least appreciate and develop some intuition for it, you start to understand why quantum mechanics as an entire structure in physics is necessary.
Yeah. I had never heard of this experiment before reading your book. How exactly, or roughly, how does it provide evidence for quantum mechanics?
So I should start by saying that actually I told a group of people at a theoretical physics workshop last year that I was doing an entire section on the Stern-Gerlach experiment, and they all looked at me like I had lost my damn mind.
Because it's complex.
And I went through a bunch of people's books for general audiences and realized that nobody was writing about this experiment.
Oh.
And one of the reasons people don't write about this, even though actually, like almost certainly at some point in one of your quantum mechanics classes, it actually did come up, and you're probably just like, you learned so many things that it didn't.
I actually never took a quantum mechanics class.
You are an astronomer who somehow managed to get away with that. Wow. Okay. That explains how you managed to avoid. But the Stern-Gerlach experiment is functionally one where the results that you would expect if the world was purely what we would call classical or Newtonian are not what actually happen. You get completely counterintuitive, unexpected results that seem to suggest that just by interacting with the experiment in a way that shouldn't change the results, you completely change what information the particles appear to, quote, know about themselves. And I'm saying quote out loud because obviously they are not thinking beings. Yeah. And one of the challenges even in talking about this experiment is figuring out what words to use to describe what actually happens. And the end product of this is that if you want to write down a mathematical formalism that describes these results, you're forced to introduce a mathematical framework that doesn't describe our classical world. So you have to go beyond the frameworks that describe our classical world. And this is what I mean, that it kind of forces the entire quantum artifice on us, is that you have to literally change the algebra that you do. And you have to change your sense of what information constitutes information about the system. Woof. And what the system actually is. And all of this is implied by the Stern-Gerlach experiment. So I was like, I want to walk people through it. And initially my idea was, I'm going to walk people through it in the first chapter. And that was actually the sample chapter I submitted with the proposal to sell the book to my publisher. And then as I wrote, I was like, that's not going to happen. There are these other things I need to do first. And actually, the sample chapter that I wrote, that was one of the hardest parts of writing the book, because I had to break that chapter into 2 different chapters. And I had to disentangle things. And that was actually pretty hard to do.
It's always going to be hard to do when you know it so well and you're so close to it. But you did it. You untangled it. It was a guided walk through this very complicated subject. And I am grateful that you started with a high-level discussion of something that a lot of people think is very simple. Like having the book open with such a nuanced piece about what time is and what space is got me mentally prepared for the Stern-Gerlach experiment in later chapters.
So I definitely think that that was, as you know, because you've also written 2 books, the book tells you about itself while it's being written. And actually, I love how in your books in particular, you turn this into a very literal element of the book, where it is somebody else telling you the story that is going down on the page. But the book really is telling you about itself. And so this was one of these things that the arc of the book did start to reveal itself. And this is when people talk about writing as thinking.
Ooh.
This is like a great example of, there's no way I could have conceived of what this book should look like without putting it down on the page. And so I know you've been doing a lot of work representing artists in terms of talking about the rise of generative AI. And this is one of those things that if you let something else do that process for you, you have not done the thinking of understanding, why does this book have the arc that it does? And having that actually reflect back to you, I didn't even know I thought that. I didn't even know I thought these concepts went in this order. Whereas like with this section on quantum mechanics in this book, I have a notebook where there are like 20 pages of me writing out, these are the things that make up quantum mechanics, and trying to figure out what order to present them in. Because they all kind of imply each other in a circular way. But again, I have to present it to the audience linearly. And I had to have a conversation with myself on the page about what order I would do that in. And I knew so I wanted to talk about Stern-Gerlach, and the other thing I wanted to do is I wanted to tell people about quantum field theory, because I just fucking love quantum field theory.
It's so interesting. Like, we're not real. We're just spikes in an energy field. That's so cool.
Exactly. We're just spikes in this is why you're a writer. I think you just did that better than I did. But we're just spikes in an energy field. Exactly. And there is some buildup that is required to get there. And I think that's one of the ways in which the book tells you about itself, is that as I was writing, I was realizing they need this piece of information. They need this piece of information. But also, I have to keep that piece of information interesting. I can't just be saying, read this because you'll need it later. It has to be interesting on its own terms, because this is not a textbook. The reader does get a choice about whether they stick with it or not. So there is this added layer that's actually different from teaching a class, where I'm teaching quantum field theory next year, actually. And the students are stuck, even if like I do a boring lecture or the chapter, they don't like that chapter, they're stuck, right? But my reader for The Edge of Spacetime can totally put the book down. And so I have to make sure that I'm convincing them at every stage that this thing is on its own interesting, and also it will be interesting in a new way later.
Yeah. And I think you nailed it, because there was no point in that explanation where I was bored. There were parts where my brain was like, let's take a little break. But there was no part where I was like, I don't need to know this. I'm going to skip ahead, because it all felt like it was leading to something. So great job.
Thank you. And I think, one of the things, and I do try and talk to the reader about this a little bit, is that there is no version of physics where you don't have to stop and think about it. That's a feature of physics. That's that's a feature of our universe. Our universe is a stop and think kind of thing. And one of the arguments that I want to make in the book is that the process of stopping and thinking about it is good for you spiritually, intellectually, politically. It's good from the politics side might surprise people, but politically you want to have practice of stopping and thinking about what's being said to you and whether you agree with it, what metaphor is being used. When someone uses a certain type of language to describe a group of people, is that humanizing or dehumanizing? Mm-hmm. What story is that person trying to tell me about not just that group of people they're talking about, but about their political commitments and their spiritual and moral commitments? And those are all embedded in the language choices that people are making. We have to practice the skill of analysis to know that. And so part of the argument I'm making also in this book is that by practicing with physics, you practice the skill that will serve you in all of these other areas of your life.
That's good. Yeah, and you're practicing it in an area that is most likely very unfamiliar to you. Most people don't have a close relationship to physics. And so you have to think about that practice. You have to think about the steps to it when you're in an unfamiliar context.
Yeah, and I think one thing that I didn't appreciate when I was writing The Disordered Cosmos was how many people would pick up the book who usually don't read science books. It's weird because I should have thought of that because that was actually one of my goals, but I kind of, I guess maybe didn't believe in myself enough. I didn't think that I would actually reach that audience. And one of the things that I learned about that audience was that people brought a lot of what I think could be bona fidely called trauma to the table because they had teachers who told them that they were stupid at math, that they had sexist physics teachers. The number of stories about sexist, it's wild. Why are you teaching high school at a school with girls in it if you're going to be like that?
Truly.
What's your damage? And so I think I was a lot more aware this time around that what happens is that people unconsciously almost think there's going to be a test at the end of the book. And so the other thing I want people to know is it's okay, actually, if you're like, that went over my head a little bit, or I'm not sure that stuck, because you might not remember why we call neutrinos non-trinary, but if I say to you neutrinos are non-trinary, you've heard that before, that's familiar, and you know where to look it up if you want to remember the details. And that's actually, believe it or not, what physicists are like. I forget a lot of stuff.
Yeah.
I have a bunch of books behind me that when I need to remember, I know which book to pick up. And that's actually part of the work. But also, again, even if you never remember anything about even what the heck a neutrino is, your mind has been shaped by the experience of reading through it. It has literally physically changed your brain.
Yeah, new pathways were made.
Yes. And that's what I want for you. There's no test at the end. Unless you want one, we can work that out. But that can be your kink. I don't know. But
True. Not mine, but I'm not going to yuck someone's testing yum.
Exactly. And I'm sure there are DOMs out there who can work that out for you.
That just opened a whole new room in my brain. Thank you for that. But that's so true. I think one idea that people feel very intimidated by, but also excited by, is the idea of the multiverse. And I noticed in your book that you called it rather frustrating as an explanation, especially in the context of universal inflation. So what is frustrating about it, and why do you think it's maybe not true?
So I will say, let me back up, and before I start talking about my frustrations, let me say a little bit about the multiverse in the physics context, because I think most people know it from the Marvel universe or Everything Everywhere All at Once or something like that, which actually I do think Everything Everywhere All at Once comes close to trying to think through the quantum mechanics version, where there's this continuously new stories splitting off. But in the context of cosmology, it often comes up. So in the case of inflation, that there are new inflationary bubbles that are basically popping off, and inflation happens eternally into the past and into the future. And so we happen to live in a bubble of space-time that has the properties that it does, and those properties are such that life can evolve like us. And there's something about that feels very anthrocentric, human-centered. And this is actually So there are various versions of what is called the anthropic principle that also kind of say, so in addition to dark matter, the other major energy matter component in the universe is something called dark energy. And this is actually more dominant than dark matter is. Visible matter is only 4% of the energy matter content in the universe. And everything else is dark matter and dark energy. Which the only thing those two things have in common is that we don't understand them. And for that reason, they were given the name dark, which, as you know, I had a lot to say about in my first book.
I still say invisible or transparent matter after reading The Disordered Cosmos.
Yes. So we have this problem of what we call dark energy, which seems to suggest that there is a baseline of energy associated with space-time that is just there. And we don't have a really good way of explaining where that baseline of energy comes from. So one of the explanations is that if it wasn't there, we wouldn't be here. And so we just happen to live in the part of space-time where that is there because we need it to exist, because it shapes and it plays a really big role in the evolution of large-scale structures like galaxies, galaxy clusters, et cetera. And so this is one version of the anthropic principle. I find this very frustrating, the idea that we just happen to live with this one value and there are many other bubbles out there and we just happen to not be in those.
Yeah. I also find that frustrating.
Right. I would prefer a mechanism that says, like, this is where the energy comes from, rather than there are lots of different space-time bubbles and they all have different values and we happen to be in the one with this value.
Okay. I had not heard. Now that I see you lay it out, I agree. It's really not satisfying. I had not heard it set up in the way of different inflationary bubbles before.
Yeah, I think that to play devil's advocate with myself, I guess, I will say that in models of inflation, and I realize I should back up and say what is inflation very quickly. So we think that basically right as the universe or space-time started or whatever happened before, there was a moment when space-time expanded exponentially. So it was very, very rapid. It went from very small to very large in less than a tiny, tiny, tiny fraction of a second. And a lot of models of inflation, if you're just kind of naturally writing down the equations, suggest that there should be lots of bubbles where this happens at the same time and kind of continuously. So some of this comes down to arguments around naturalness. And this actually, natural has a technical definition in particle physics that I don't get into in the book.
Ooh, okay.
But I will say there is a technical definition, and there's debates about what models are natural or not. But there's an argument to be made that these, what are called eternal inflation models, are natural. So it simply may be the case that we do live in a universe where there are going to be bubbles that have these different values. And to play devil's advocate with myself, there is a good mechanism that would explain the creation of this kind of universe. I just still think that we should be curious about whether there are other ways that you can explain that baseline of energy, that dark energy.
Mm-hmm. Do you have ideas for other ways to explain it, or is that beyond the scope of this work?
I mean, I write in the book about, so I mentioned that my dissertation was not on dark matter. I am actually, I guess, a cosmic acceleration baby. So I was graduating from high school when it was discovered that space-time was not only expanding, but actually that expansion was accelerating. So it was picking up speed. It's like when you hit the gas when you're getting on the freeway. This is called cosmic acceleration, and dark energy is the most popularly known solution to it. So it's sometimes called the dark energy problem. I prefer to call it the cosmic acceleration problem. And what I wrote about in my dissertation was that maybe this piece of information about space-time was our first hint about quantum gravity, about how we should merge quantum mechanics and gravity together. I still find that to be really interesting and kind of spiritually feel committed to it. But also as you know, we were discussing earlier, you have to be ready for your worldview to be changed. And so I have to be open to the possibility that that's not the right way to think about it. So I try and keep an open mind, especially because I don't do research on that anymore.
I love that you are keeping that open mind. That was one of the things I respected so much about science, but couldn't personally handle. Because once I realized that doing science is more about admitting that there's so much you don't know instead of saying, I know this now, I became less interested in doing the research. but that's just like a personal thing about me. I'd rather share knowledge that has already been gained than gain the knowledge myself.
But I think also, I know I'm not interviewing you, but I guess I just want to say in your work, I think one of the really innovative things that you do is you come up with these extraordinarily creative, new, never done before ways of telling people stories that may be familiar to them, but will not be familiar in the way that you have cast them. And I think that there is something really powerful about that. And that is part of the process of bringing people into the work. So I just want to acknowledge that that may have been a form of creativity that you were less excited about, but you found another way to relate to it with a different type of creativity. And I think it's been very productive and helpful for us as a community.
Well, thank you. Now I'm blushing. I appreciate that. Well, going off of that, my final question has to do with the connection between science and myth. I saw it in the book and I couldn't not ask you about it. You say that you see humanity on the very edge of myth and science. So how do you see the two operating with or against each other?
Ooh, I should have been prepared for this question.
If there was any question I was going to ask, it would have been this one.
I mean, I think as a theoretical physicist, my job is to imagine things that may not be.
Yeah.
And in that sense, we are myth making. That's not to say we don't have rules, but also myth has its own rules, right?
Yes.
And I think this is one of the reasons in many ways, you know, the subtitle of the book is Particles, Poetry, and the Cosmic Dream Boogie. And in a way, I'm arguing against, a lot of people say like, oh, science and art go together. I'm actually arguing against the idea that science should be thought of as a non-humanist, non-creative practice, but more understood as a humanist and creative practice that has a specific set of rules that it's engaging with, technical rules and technique rules that are actually also always in conversation. Socially, we're always navigating, are these techniques actually the best ones? Are there better techniques? Trying to think about like how, for example, race and gender actually shape scientific outcomes invites us to think that actually we need to be conscious of those social elements in order to do better, quote, objective science, right? And a lot of our job in theoretical physics is to think of things that are wrong. We just don't know which of them is the wrong thing, but they can't all be correct, at least not in our universe, right? So I don't see so much difference from myth in that this involves some creativity, this involves some leaps of faith, and involves a kind of curiosity about what story could be told. It just happens to be that there are certain mathematical rules that we have to be responsible to in that process. And those are going to be different from myth doesn't obey those same mathematical rules, but it's all universe building. I have to say I'm on a mini campaign. We shouldn't say world building anymore. We should say universe building.
Okay. Can you say more about that?
I just think most of the time people, especially if you're doing like space science fiction, you're universe building.
That's so true. That's so true.
But I think there's also kind of an invitation when you say universe as opposed to world that invites you to think expansively of what is the solar system that Middle Earth is in. If Middle Earth is on Earth, like what is their understanding of Earth's physical location? Do they have a sense of the galaxy? And I have to say, I've been thinking a lot about Tolkien recently because of The Lord of the Rings in relation to World War I and the way he was processing what was called the Great War at the time and The Lord of the Rings. So this is one of the reasons that's an example I'm bringing up. But I also think about Tracy Deon's Legendborn series, which is, I'm friends with Tracy, so I can tell people like, the depth of like universe building that she is doing, there are things she knows about the characters that are not on the page because she knows like they have whole worlds, whole lives, whole universes.
Yeah.
And
I hear she spent like a whole year working on the magic system before she started writing.
She is, I've advised on a couple of her books and the level of brilliance that she brings to that series. The books speak for themselves, but as someone who gets to see some of the other side of it, I actually feel like the world doesn't appreciate even half of like the level of genius that she's bringing to the page. And part of that is that you make choices once you put things on the page, but there are things that are on the cutting room floor. And the reason what ends up on the page looks so good is because there's so much that is shaping. There's a whole universe you have built for this person, so that even if they play a small role in the story, there's a feeling you're able to give to the reader because you have that feeling as the writer. And that comes from the universe building part. So I just think there's a whole universe of people happening when people write stories.
There really is. There is. I feel like every time I talk to you, I come away with wanting to shift my vocabulary. So watch me using universe building from now on. That's so exciting. And I could talk to you about the connection between science and myth forever. One of the things I appreciate so much about myth, and it's something science doesn't do well yet, maybe, is that myth lets you hold multiple truths at once. And I think maybe for theoretical sciences, that's a closer comparison than in more observational sciences.
It's interesting because I think in physics, we do have a sense of domain. And I mean that in like the non-colonial way. I mean, there's also definitely a colonial sense of domain, but there's a sense of here's when you use Newtonian mechanics. Here's when you use quantum mechanics. Here's when you use statistical mechanics. These are just like three different, and the listeners don't need to know what the difference between those three things is, except to say that they all apply to different length scales, speed scales, and number of particles involved, right? And part of your training as a scientist is learning when one world applies and one set of equations applies, and when busting out those equations are actually totally useless to you. And so I think in that sense, we do have some built-in understanding of when it's appropriate for physics to be commentating on something and when something is beyond the realm of physics. And it would be good for us to broaden that understanding into a more humility about how when we talk about truth, there is the physicality of the world, but there is also how people interpret that. And that interpretation becomes part of our social narrative and how people actually experience their lives. And there is an element of that. I don't know how we want to say what's true or not, but there is truth in people's witnessing of the world that isn't just about calculations that we do. And it's important to reckon with that.
Mm-hmm. I think that that's a great note to land on. Do you have any final thoughts on the book that you want to share?
I really want people to feel welcomed into the book, and you don't have to be a person who has been excited about physics. You can actually be a person who hated physics. I invite you to at least read the introduction.
Please.
If nothing else, I hope that when you get an opportunity to look at a dark night sky, that you will take it and look up and just let yourself be with it.
Please. Yeah, that would be great. And you are touring with the book, so people can pick up their book in their indie bookstore and maybe meet you along the way?
Yes, I will be in DC, Los Angeles, Chicago, San Francisco, both Portlands, St. Louis. Did I say San Francisco already?
Yeah,
Boston a couple of times, a couple of places in New Hampshire. So these will mostly be happening in April. In June, I'll also be in Tulsa, Oklahoma in September. So please do come say hello. And you can find information about the tour on the Penguin Random House website for the book.
Great. That link is in the episode description, so you can head on down there and plan your Edge of Space Time visit, which I encourage everyone to do.
Thank you.
The last thing I want to leave everyone with is what I think might be my favorite quote from The Edge of Space Time. And it's that the universe is too fucking fabulous for capitalism. And I hope we can all keep that in mind. Remember that you are fabulous because you are space.
I love that. Thank you.
Thank you so much for joining me, Chanda. I've really had a great time talking to you.
Pale Blue Pod is hosted by Dr. Moiya McTier and Connie Gibbs. Moiya created the show with the funny and talented Karine Caputo with help from the Multitude Productions team.
Our theme music is by Evan Johnston, our cover art by Shay McMullen, and our audio editing is handled by the superlative Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Instagram or check out our website, palebluepod.com.
I, Moiya, am Go Astro Mo on all socials.
And I'm @ConStar24 on Instagram.
If you want to support our show, join our community at patreon.com/palebluepod or send this episode to your family and friends group chats.
We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
Thanks for listening to Pale Blue Pod. We'll be back next week.